go to page 20 in your journal and copy down the definitions for some of these vocabulary words. Now we want to take a look at solving a three-variable system. So if we have three equations and three variables, these are the steps that you want to follow. So you want to take a look at step 1, step 2, and step 3 and read them over. We're going to take a look at examples in our notes packet. So go to example 1, starting with 1.4, and we want to solve this system. To solve example 1, I'm going to look at this like equation A, B, and C instead of 1, 2, 3. So I'm going to label each of them A, B, C. And I want to pick one variable to eliminate. So in this case, for me, I think it's easy to eliminate the y's if I get negative 2y in equation C. So if I multiply that by 2, I can add equation A, and I know negative 2y will cancel the 2y. So I'm going to, over here, write 12x minus 2y plus 8z equals negative 6. And then 4x plus 2y plus 3z equals 12. Then I'm going to just combine like terms and add this going down. So I did 2 times equation C plus equation A. Okay, that's what I'm doing right now. So let's combine these terms going down. I'll get 16x, 2y's cancel, plus 11z equals 6. I'm going to call this equation D. So this is my equation D. Now I want to use equation B somehow and cancel out the y's again. So if I multiply equation C instead of by 2, if I multiply by negative 3 and then add equation B, then I'm going to get, negative 18x plus 3y minus 12z equals 9. And then 2x minus 3y plus 5z equals negative 7. That's equation B. So if I add these up, I'm going to get negative 16x, cancel the y's, minus 7z equals 2. Let's call that equation E. Now I want to put equations D and E together and then solve for the missing variable. I just wrote equation E below equation D. The x's cancel out and I'm left with 4z equals 8. So divide both sides by 4 and I'm going to get z equals what? Good, I get z equals 2. So now I'm going to take equation D and I'm going to plug z back in for this z right here to solve for x. So I'll get 16x plus 11 times 2 equals 6. So that's 22. 16x, 6 minus 22 is going to be equals negative 16. And then divide both sides by 16 to get x equals what? So x equals negative 1. And then my last step is going to be substitute in your z and your x into one of these equations. I'm just going to pick the first one and then solve for the y. So you can see I took equation A and I plugged in my x value and my z value. And then when I multiplied and solved the problem, I ended up with 2y equals 10. So y is going to equal, so you're going to get y equals 5. And your final answer, you want to write it like an ordered pair, x comma y comma z. So our final answer will be negative 1 comma 5 comma 2. to do example 2, this is going to be a little bit different because it says no solution, solving a 3-variable system with no solution. So I know it's going to look a lot different than what we just did. We want to do the same thing by eliminating a variable, and it looks like I could eliminate x and 5x if I just multiply equation A by -5. So I'm going to do -5a plus equation B. Let's see what happens if I do that. That will be -5x minus 5y minus 5z equals -10. That's -5a, and then I have 5x plus 5y plus 5z equals 3. So if I add these all up, the x's go away, the y's cancel, and the z's cancel, so I'm left with 0. And then on the other side, I'm left with -7. So 0 is not equal to -7. This is a false statement. Therefore, there's no solution. You don't have to do any more work. This system has no solutions because it's a false statement. Then if we look at example 3, and I look at my equations A, B, and C, I want to cancel out my, let's cancel out my z's. If I just add equation A plus B, it'll cancel my z's. So I'll get x minus y plus z equals -3. X minus y minus z equals -3. So if I add these equations, I cancel out my z's, and I get 2x minus 2y equals -6. Then I can also cancel my z's by adding equations b plus c. So I have x minus y minus z equals -3, and 5x minus 5y plus z equals -15. If I add these all up, I'm going to get 6x minus 6y, z's cancel, equals -18. And now I have my equations D and E similar to example 1. I want to set those up, equations D and E, so that I can try to cancel one of the variables. So if I multiply equation D by -3, then I would get -6x here, and it would cancel out with the 6x that I have in my equation E. So I'm going to write that below. This is -3 times D. So we have -6x plus 6y equals 18. And now when I add these, my 6x's cancel, my 6y's cancel, and -18 plus 18 cancels as well, and it's all 0. 0 equals 0 is a true statement. Therefore, my answer is infinitely many solutions. So in example 2, it was a false statement, so it was no solution. And in example 3, it's a true statement, so we say infinitely many solutions. Bring your journal and pack it to class, and we'll try the monitoring progress, and we'll do some more examples tomorrow.